hope you over there hear me as well. Mr. Kennan asked me to remind everyone that if you don't follow the presentations, you don't get a lunch. Is that correct? Okay. Okay, so if you sit, you are eligible for the lunch. Good move, good move. You must be Dutch. Okay, so I will speak for the cameras if nothing else. I will talk about condition-based lubrication and condition monitoring as a one set, and ultrasound as a first line of defense in what we need today to make bearings living proper life. My name is Haris Trobradovic. The name is complicated even in my country, so don't try to think about it. Just say Haris, it's going to be enough. I'm coming from SDT Ultrasound Solutions since 1975, which is called a young company. We help industry to avoid failures through a proper condition monitoring, finding problems in time, and preventing problems in the first place. So I will try to give a little bit of overview of the backdrop of what we are talking about today. It's that here we are. In 21st century, some of us accepting it faster, some of us slower. It's a hyper-fast technology development. It really is hyper-fast. You are out of work one day and you're already late. It's hyper-fast, but everything is happening in the same time. It's going very fast and it's going very, very far up. What I would like to know is how everyone is involved. What we see today in industry is something that some clever people predicted 15, 20 years ago. It's this. When you have a typical team in any industry, you have an average, a white noise, and you have some peaks. Those peaks are top experts who are following the improvement of the technology. They're going very far, very up. Now, that was the situation 15, 20 years ago. And some clever people said, we might have a problem because this is what happened. The peaks rise. The peaks rise very high. So now you have a top experts accepting technology and going very, very up, very fast. What happened with the average? Doesn't move very much. And that's a serious problem. Because what we do need in industry is to move that up, but to move this up. Because the rise of the peak is not so valuable as the rise of the RMS. Those of you who are doing vibrational ultrasound, you know what I'm talking about. You need to rise the average knowledge. Rising several peaks and several people in a company is never enough. It never brought any real benefit. So in Industry 4.0, we need to address this. Requires people 4.0. You cannot have Industry 4.0 with people 1.0 and 2.0. That simply doesn't work. Because the more automation you get, the more trivial problems will kill our process. So we do need humans 4.0. And things like this, how many people use improved technology? Think about any facility if you are working in a production, in a manufacturing. Think about your clients if you are selling them bearings. How many people in that company are actually involved in using high tech, especially in condition monitoring? Like vibration, oil analysis, thermography, ultrasound, and whatever. Not very much. Very small number of people. And those people are getting better and better, but the number is very, very limited. How many people do improve? Not so much. Not enough. Definitely not enough. Because what we see today is this. We are going very far up with IoT. We are here improving dramatically. And of course, you will always have a screwdriver and a human sensory. That's absolutely okay. And the reality is this. It has always been. You have top experts improving. You have specialists doing certain jobs and engineers. You have technicians and you have everyone. So that's a structure of your everyday team in industry. What we see now, it's quite problematic. That this area of people are improving dramatically because they can follow up with the technology. But what happens with the rest? They stay here. I'm deeply involved in training and implementation, and I'm very sad to see this every day. And it's not good. We need to train everyone. We need to make sure that the whole pyramid goes up, not just parts. because those guys will never have time enough to do everything without the help from below. So we need to consider transition to Human 4.0 as well. Sentences like, not for me, too complicated, not my job, that's not an option anymore. Do you hear these sentences in industry? Probably daily. Oh, that's not my job. Oh, it's way too complicated for me. Someone else will do it. When that guy is someone else, it's really fantastic because everywhere I go in the world, I meet someone else. And the guy is everywhere, doing all the jobs. In Italy, they call it Simone Van Elsie. In Netherlands, it's someone else. But it's always someone else. But it's no one else, actually. It's his evil brother. This is not an option anymore. We cannot accept this. Companies cannot accept this. It's too expensive. Now, the real value of the company is people. Don't tell me about technology. Don't tell me about the machines. Everybody can buy machines. Everybody can set up the process. The real value of the company is people. The difference between profitable and bankrupted company is in the people, not in the machines. So why do we keep investing only in the machines and not thinking about investing in the people? That's quite ludicrous. It's digging your own grave, especially financially. So we need to include more people with more technologies. Wide when applicable, sometimes very wide, sometimes very narrow and targeted, sometimes one application. But we need to get everyone using a proper technology to go up, and you will pretty soon see why. How many people are involved in any kind of condition monitoring in the companies you know? Mark, what is the number? Sometimes it's none. So condition monitoring is zero. So that means we invest $5 to $10 million in the asset, and then we invest $0 in the people monitoring that asset. That's quite crazy. Makes no sense at all. So this, hear no evil, see no evil, speak no evil, small-time politics in a company. A company doesn't need this. No matter how much people think that's a good way for my career, that's a BS. And I mean bad science, not the other thing. That's a BS, that doesn't work. Company doesn't need this. People don't need this. They don't like this. Everybody wants to go up. But the question is, do they have a chance? Do they get a break? Do you invite your grease guy, the grease technician, for the training? Do you see any grease technician on conferences like this? Never. So we don't care about that. That's not important. Bloody hell, it's very important. So everyone who touches bearings, and it's in red font, must be highly competent and equipped. What's the point in manufacturing the top bearing, transporting it in a careful way, storing it perfectly, and doing all this stuff, and then it gets in the hand of the incompetent and unequipped guys? What's the point? You can as well produce garbage, because the result will be the same. Why do you spend so much money in manufacturing the top quality bearings? You should see how they die. Not like heroes. So bearings are never villains. Never. Never blame the bearing. I was happy to work with Per Arnold Ekquist Olsson, who told me 50 years ago, we had some discussions about the qualities in bearings. Today, zero. The quality issues are measured in ppms. So there's no excuse about bearing quality. Bearing is never guilty, but it's a fantastic excuse. Whatever happens, oh, it's a bad bearing. Let's change the brand. No. If you keep on doing the same thing, you can change all the brands you want. The outcome will be the same. You will not change absolutely anything. Most of the bearings die because people kill them. And they do. They just simply go out and kill the bearings. 60% of the bearings die because of the improper lubrication. Is that a tragedy? But that's not a complete tragedy. The complete tragedy is that we have these statistics for 40 years. So for 40 years, we know that the 60% of the bearings die, and we do nothing. That's okay. That's okay. It's going to be fine one day. So it's as simple as your personal health, the way you treat your body, Just do the same thing with your assets, nothing more than that. Eliminate every illness you can by living a healthy life. Don't drink, don't smoke, don't eat fat, take care of cholesterol, blah, 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 and exercise a little bit. So that's what you do to keep your body fit. And, so that's a step one. Diagnose all else as early as you can. If something, God forbid, happens, and sometimes it does, you should diagnose it as soon as you can, as early as you can, and you'll be fine. So there are two issues, just two issues. It's not a rocket science, everybody can do that. So when it comes to bearings, we should treat them the same way. Really, it's not so difficult and it's so problematic. Proper bearing for the purpose, properly handled in transport and storage, properly installed, not with a big juicy hammer, properly lubricated, and if something goes wrong, God forbid, and it will one day, detect it in an early stage. How difficult could it be? You would be very surprised how this is difficult. How this is difficult. Oh my God. Companies are struggling for years to even understand that this needs to be done properly. So the proper lubrication. Why do we lubricate? Is lubrication important? Come on, I know I'm first one in the morning, you still didn't have your coffee properly. Let's lift it up. Is lubrication important? Hey, I know for you. I know for you. Yes or no? Okay, on the scale 1 to 100, how important is lubrication? 1. You said 1? Ah, the most important. Okay, okay, in that way. So do we have a consensus that it's a highly important strategic job, somewhere between 95 and 100% of importance? Do we have consensus on that? Good. How many of you have sons? Come on. How many of you have sons? Do you dream that your son one day will be a grease guy? No. Honest answer. But 10 seconds ago you told me that it's absolute priority job. How does that work? You see the paradox? So you all say that's a highly important job. Oh my God, it's a top importance job. Not my son. No, no, no. My son will be a doctor, lawyer, politician, maybe organized crime. That's a very, very, very lucrative business, but not a grease guy. Come on. Because the grease guys stink. It's a dirty job, no future, no education, no respect, no improvement, no nothing. So bloody hell, it's a paradox. We just said it's a highly important job, and then we give it to the lowest ranked people. So do you still want to blame them? No. No. Our grease guys are product of the system. You have the wrong system, not the wrong grease guy. Where's the grease guy in this conference? 0. They never come. They don't know how to eat properly. Maybe that's the reason. So why do we lubricate? The grease guy is never trained because he's a cost. The grease is a cost. The greasing is a cost. Okay, so let's define this once for all. Why do we lubricate? Can anyone tell me? You are from the bearing worlds. Tell me, why do we lubricate? Reduce friction? Sorry? Okay, stop metal-to-metal contact. Come on. Save energy. Reduce wear. Okay, dissipate heat. There are a lot of stuff. Okay. Reduce friction, reduce wear, control contamination, dissipate heat. We all agree with that? So that's why we lubricate? No, no. This is correct, and it's absolutely useless. And I'm telling this with a full responsibility. It's completely useless. Because it's incomplete. It's incomplete. Please, go to your top manager, who is probably a lawyer, economist, or whatever, or MBA, and try to speak about kappa value, viscosity index, la, 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 la. And tell me, will you get the funding for your lubrication improvement? Bloody hell, no. The guy will say, oh my God, just leave my office. I have no idea what you're talking about. Because he doesn't understand you. Because he doesn't understand you. Because you try to speak about things that people who need to green light your initiative have no idea about. Of course, lubrication is a cost because it's presented that way. Because when you speak about this, you are speaking in an echo chamber. You are talking to the people who understand you anyway. So why do we need to talk to people? We understand each other anyway, so that's not a problem. We need to translate it to the language of the people who don't understand lubrication. We cannot improve because management doesn't see it as a priority. I hear this every single day. We cannot improve. They don't see it as a priority. They don't give a budget. Of course. Try again with the friction contamination, kappa value index, or viscosity index, and you will see that you can do it all the way until the kingdom come, and you will achieve nothing. So this is boring and irrelevant. Why do we lubricate? To achieve business targets. That's the only reason we lubricate, to achieve business targets. We lubricate so we can produce 24/7 without interruption, without downtime, with a full production capacity, with a top quality, and make money. That's the only reason why we lubricate. So I'm coming from the lubrication world just like you, and if you want to fight over this, I'll be happy to get a fight. Reduce downtime, produce more, increase profit. When you talk about this, you get everyone's attention. Now everybody is listening because you are talking about money. Just to prove my point, tell me, if you want to start an electrical motor with a completely dry bearings, 0 grease, completely dry, will it rotate? Yes. So, do you agree with me when I say that lubricant is not necessary? Lubricant is not absolutely necessary. This motor will rotate. So lubricant is not necessary. What will happen when you start the motor with the dry bearings? It will die. 6 hours, 6 days, or 2 weeks. So we put grease. Why? To make it run cheaper and longer. So if my logic works, and I'm a mathematician by my original education, if my equation works, we lubricate to get money. Because it will work without lubricant as well, only a little bit more costly. So it's all about money. We need to put lubrication as a profit center, not as a cost. It should be in a different column. And thanks to the people who keep on talking about friction, wear, contamination, kappa value, la 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 la, to the managers, they put lubrication in a cost. Start talking about a profit, and you will be in a different column. Once you're in a different column, you get investment. You cannot get investment if you're not creating profit. It's a simple economic rule. Good. So this doesn't look profitable to me. If we lubricate to get profit, so that means if we lubricate more, we get more profit. It works with baklava, definitely. It works with beer, right, Mark? But it doesn't work with grease. So this grease didn't enter the bearing by the Holy Spirit. Somebody pushed it in. What about this one? Look at this beauty here. You just need to smell it. It's acidic. It's heavily over-lubricated. This bearing is failing every 2.5, 3 months. It's so hot that they even cool it down with a compressed air. That's a very good idea. So that doesn't look profitable at all. Look at this poor old bastard. The best of his life. Okay, so who's the grease guy? Who is the person in the company who has the most intimate contact with the asset? Have you ever think about the fact, who is the person in a company that has the most intimate contact with the machine? The grease guy. He's the only one putting something inside. Please don't say vibration analyst, ultrasound analyst. I'm in that group, and I'm telling you, all we do is we observe. We are harmless. We cannot harm the machine. So this is a reality. Around this motor, there is maybe good vibration analyst, education and training high. Oil analysis, education and training high. White collar people. Saul Goodman, infrared thermography, education and training high. Bartender, ultrasound, Hi. What are these guys doing? Observing. So we all take this expensive equipment, we come next to the machine, put the sensor, we try to look smart because we are paid usually quite well, and you try to look smart and you are analyzing the situation. And then we simply miss the guy who is creating the situation. But we keep on observing this situation. You know, we put the sensor and trying to be smart. He is here unnoticed. He's no name, nobody. But he is actually the only one who interacts with the machine. He changes the condition. So I think we should focus on that guy primarily. So the diagnosis in industry today, those 60% of the failed bearings, no real cost assigned to the failure. Because people say failure is cost of the bearing and cost of the wrench time. Stupidity. Bearing is irrelevant. Bearing is not a cost. The downtime is a cost. So that's a problem number one. Lubrication is usually at the end of the food chain, given no importance. So you cannot expect any good results out of that. Lack of communication, involvement, discipline, control, certainly a problem. Wrong approach, assumption-based. I'm sure there will be a lot of people screaming and shouting at me, but I will stand my position. Lack of data, and of course, at the end, lack of culture, lubrication culture. The examples you have seen before, that's not technology. That's a pure lack of culture. These are the issues we need to resolve, but I want to address two things. Wrong approach and lack of data parts. So about the wrong approach, time-based approach, how many of you are advocating or using or teaching time-based approach in lubrication? So that means you need to put 30 grams of grease every no. How many of you are involved in that? Okay, good. Where are those recommendations coming from? Where are the numbers coming from? This is fascinating. People don't ask that question. You have to put 25 grams every 3,000 hours. Yes, sir. And nobody even asks a question, where does the numbers coming from? How are those recommendations calculated? How? How do you calculate that? How do you calculate the same pump working in oil and gas in Oman and in Novosibirsk, which is obviously completely different conditions, right? But yeah, we will calculate that. We will sit in Finland in some office and we'll calculate that, don't worry. It doesn't work that way. Because this is what you end up with. You have bearings on one shaft, drive end and non-drive end. 6318 C3. Cool? Same bearing, same shaft, same rotating speed. So you put the same grease. First of all, they say you need to lubricate drive end and non-drive end the same. So they forget the fundamental issues, Tribeck curve. Load is different, correct? If the load is different, how can lubrication be the same? But the calculation says, oh, it's okay, just smack it in the middle, it's gonna be fine. It's gonna be average. So that's problem number one. Problem number two, you need to lubricate every 3,068 hours. Listen to that beautiful number, 3,068. So that means you should not lubricate after the lunch. It's going to be too late. You have to lubricate before the lunch. So the person who wrote this obviously never spent a day in industry. And I don't want to trust a person who never spent a day in industry. Because what do you mean 3,068? That's not the way it works in industry. That's for problem number one. Problem number two, nobody can be that precise. So this guy is sending a message. I'm so precise. I will tell you exactly in hours. That's very, very problematic. And then you need to put 32.7 grams of grease. I'm trying for the last 10 years to put this 0.7. Can you put this 0.7? No. I had a friend in high school. He had this very precise scale. Now he's in jail. He was measuring completely wrong stuff. But I was never able to put this 0.7. So if we cannot put 0.7, how comes that this guy doesn't know that? Because he never held a grease gun in his life. And we still trust this calculation. So it's theoretical estimates corrected by assumptions. Let's give things a right name. There are a lot of different formulas. They all boil down the same. And I don't have a problem with formulas. As I told you, I love mathematics. I'm a mathematician. The formula is correct. The problem is garbage in, garbage out. The problem is the data you put in. So if you look at this one, which is certainly correct, you calculate all this, let's not go through that, and then you have to put the speed. What about variable speed motors? Mark, what is the average of variable speed motors in the companies you inspect? But what is the average of the variable speed and frequency against conventional? Yeah. So you don't know the speed, right? Oh, it doesn't matter. We'll put the average. Average is not a good thing because statistics is the only legal way to lie. So you have a round problem here. Next problem, temperature. People forget it's from 0, 1 to 1. It's a big factor. It's not 10%, it's 10 times. 10 times. So you don't know the temperature because it changes through the year. Then what is the contamination? I don't know. Let's check. Or we cannot check. So let's assume. Okay. Number 3, humidity. You have 4 categories. You have all of them in 1 year in most of the countries. So which one you choose? Eeny, meeny, miny, mo. And then you need to remember that vibration is never flat line. And there are some factors that are not even here. Start-stop regime. Is the machine in a continuous operation or it's on demand? So I can guarantee you, because I did it myself, the educated mistake is 9 times. The educated mistake, if you are sitting in the industry, right there, calculating lubrication for that application, you can have an educated mistake by 9 times. You may be lucky, maybe you're not. Okay, so let's see it in the same example that I showed you before. 3,068 hours, 32.7 grams of grease. So what we did is we lubricated, but this time we measure. I believe in data. Everybody has an opinion. So this is before lubrication, and this is after 32.7 grams of grease. Shoot up over lubrication. That's a huge problem. This is a drive end bearing. We put 16 grams of grease, and we had a correct lubrication. If you want to hear it, oh, we don't have a sound, right? Okay, so this is a signal before lubrication and signal after lubrication. Dramatic difference. We need a sound. Or I can just zzz. I can do it myself. Okay? Put it up. So that's a drive end before lubrication. This is non-drive end before lubrication. It's perfect. It's beautiful. Then normally you should not touch it. So the grease guy should take the measurement, say goodbye, and go away. But instead of that, it was lubricated. And it went into over-lubrication. So condition now is worse. We pay the grease guy, we pay for the grease, we pay for the bearings, and somehow we keep on destroying it. It's quite ludicrous. But there is a proof, there is a technology that can prove what you are doing and what you should be doing. So this is a case, you remember this case, Mark, this was in Bulgaria. So we should be adding every 3,000, 2 hours, the quantity is 35 grams, both sides, drive end and non-drive end. That's very suspicious to start with. So the reality was that in a motor number 1, drive end needed 24 grams to be perfect. Non-drive end didn't need any grease. So the calculation says shoot 35 grams in both of them. The reality says that they are in a completely different condition. Their needs are completely different. So this one needed 24, not 35. This one needed 0, not 35. And this electrical motor number 2, they are same. Drive end needed 19 grams, non-drive end needed 16 grams. That's the real time. That's the real condition at that moment. It has, unfortunately, nothing to do with the projection. 35 grams every 3,000 hours. This is the real condition. And this is the time waveform and spectrum before lubrication and after lubrication. So now it purrs like a kitten, but you can see the numbers. Of course, it's not always easy to recognize the numbers, but there is another taboo question, that this, or calculation, ends up with this, a check mark, usually green check mark. And God knows what really happened. So you see the problem here, that we have a theoretical calculation, and then we have a check mark. It looks to me like a Yoda. You will not ask any questions, because you don't have the data. So we have no data what really happened. Think about this. When you are balancing the machine, will you pay the invoice for balancing of the machine if the guy comes every 6 months and say, I balanced your machine, it's okay now? You will not pay that invoice. You say, show me the condition before, show me the process, and show me the condition after. Then it's okay. Alignment, the same thing. What was the condition before? How did you align the machine? What is the condition after? So that's quite normal. And I assume all other jobs in maintenance are done in this way. But imagine you have a job that we don't know condition before. We have no idea what's the condition. We decide to do it. We have no idea how it needs to be done, but still we do it. We have absolutely no idea what is the condition after, but that's okay. We have a hope. So that's how lubrication is mostly done. You don't know if it needs to be done. You don't know how, you don't know the outcome. So it's like closing your eyes and running through the minefield. You might get lucky, but usually you don't. So condition-based lubrication is asking 3 questions, fundamental questions. This is the beginning and the end of the training. Does bearing need grease? Yes or no? If you don't have that answer on hand, don't touch. Remember what I said in the beginning, only highly qualified people should touch bearings. So you don't have the answer, get out. Don't touch the bearing. If the answer is yes, how much? How much? So you need to have the live measurement telling you what's going on, because it's going to be different every time. And at the end, is it better now? You better don't come back to the office without that answer. Because imagine somebody is operating your grandfather and you are waiting outside and the doctor comes and say, yeah, we just did operation. How is my granny? I have no idea. But I did the job. How? It's unacceptable. It cannot work that way. And this is how it works in the practice. Because after XYZ years of research and development within SDT, we have an algorithm that is giving you basically instructions on the screen. So the instrument, the sensor is connected to the machine together with a grease gun. The instrument is telling you lubrication is needed. You can use guided mode as a navigation, take me home. And then it says, okay, give me 10 shots and press enter. So now, nice and slowly, you give 10 shots. You press enter. The data is live, real-time, processed immediately. And it says, okay, cool, it's going in a good direction. Give me 6 shots now. Now you give 6 shots of grease. You press enter. And then you let the data being processed, live, on spot. This is something that every grease guy can understand. Okay, now give me 4 shots and press enter. Nice and slowly, you give 4 shots. Data is being processed. And at a certain moment, it says, okay, we are done. Task completed. Success, go to another machine. Simple and straightforward. What is very important is that behind this process in the field with the grease guy lies a lot of data. The details about complete ultrasound trending, what is going on with the signal, this is typical condition monitoring, performance KPI, lubrication behavior, each point of lubrication. So imagine the transition from no data to sometimes too much data. Because now, if somebody wakes you up in the 2 o'clock in the morning and say, what happened with that bearing last year on a Thanksgiving? I can tell you, no problem. It's there. Every single process is there. within a second. And of course, you have condition monitoring data, which is time waveform and spectrum before and after lubrication. Now your grease guy becomes a condition monitoring person, taking care of the health of your bearings. Now it can also be done online, of course. This is the newest development. It's a patented Lubrain algorithm. There is a permanent sensor acquiring condition of the bearing 24/7. The data is processed through the Lubrain algorithm, and once the lubrication is needed, the signal goes to the single point lubricator, which adds exact amount of grease directed by the Lubrain. And then it's immediately measured, and then the lube starts. So the Lubrain algorithm is controlling the process, the measurement is live, and it's completely without human intervention. So in some cases it looks nice and clean, in some cases a little bit less nice and clean, but it still works perfectly. So it's an 8-channel system. You put in asset information, you choose your strategy and your algorithms, and if you want to watch, it looks like this. So you add grease, and this is the signal. You don't need to watch it ever, but trust me, it's very interesting. It's very cool. You actually see how the things are happening. This is an interesting piece of data about the bearings. This is a group of electrical motor in a very sensitive industry. Until July 2020, time-based lubrication practice. The average temperature 20 to 50 degrees Celsius on the group of motors. From July 2020, they moved to condition-based lubrication. The average temperature dropped to 15 to 40 degrees Celsius. If the top management doesn't understand the friction and wear, I'm sure they understand temperature very well. Cool machine is good machine. Hot machine is not very healthy, and it spends more energy. And this is something that Mr. Mark Gurney and I are working together on. This is just a preliminary view to show you that there is a proof that the proper lubrication has a huge impact on energy saving. Because the friction and heat, the friction needs to be overcome, and it's done by the energy we invest in the machine. So we pay for the friction, we pay for the heat. Less friction, less heat, more money in the pocket. But sometimes things happen. So proper lubrication is just what your primary medicine doctor tells you. Don't smoke, don't drink, don't eat too much meat, and exercise. So that's your lubrication. But sometimes you get sick. But it's very important to detect problems very, very early, in early stage. So that means that a multi-technology approach is a must. There is no best technology. I'm coming from the ultrasound world. I'm doing also vibration and thermography. But you will never hear from me, ultrasound is the best, because that's wrong. The same thing, vibration analysis is not the best. Thermography is not the best. There is no best technology. There is a best combination of technologies that will be capable of detecting all the failure modes that you might have in your machine, because you don't have one failure mode. You have hundreds of different failure modes. So you need different technologies. So ultrasound is a very early detection technology, so that means extremely useful for bearings and gearboxes, couplings as well. High sensitivity to friction and impact, high frequency monitoring. So that means you are able to find very short events, very short impacts that are characteristic for the early stage of the failure. And here are several examples. Instead of theory, I will just go through examples. So this is food and beverage industry in Southeast Europe. Very limited number of people in condition monitoring team, as usual, unfortunately. Process team was involved with ultrasound, and they took over 2 dryers, 3 decanters, and 48 pumps. They say, we will take care about this. Very generous, very nice move. That left huge, very big available time for the condition monitoring team to focus on the other stuff. So this is the dryer, main bearings on a dryer, a non-drive end, 4.75 RPM. Usually it's practically impossible with vibration. But with ultrasound, it doesn't matter, honestly, because people sometimes say, how low can you go? Well, how many sandwiches you can give me until I take the measurement? There's no limit in speed. The slowest I did was 0.25 RPM, and we had no problem detecting it. So this is the mint condition. The team was monitoring it from the perfect to the dismantling. It's working nice, 4.75 RPM, until one day. So they found the problem in the earliest stage and then followed it up until the last one. It's a clear BPFO, delta T 0.52. If you believe in spectrum, here is the spectrum showing you absolutely the same thing. Now, this is a critical asset, that the unpredicted failure would cause 10 days of downtime. 10 days of downtime with $500,000 of a daily rate production. That's a lot of money in any currency. So it's detected very early. They planned replacement, the minimum possible downtime. Everything went nice and smooth. It was all done by a process team. Now, this one is also very interesting. It's a coffee manufacturer in Italy. Maintenance technicians are using ultrasound to check on themselves. So they're checking on their colleagues after the installation. So this was post-bearing replacement checkup on a coffee densifier. That means that they installed the bearings. Remember what I told in the bearing? A bearing is never a villain. Don't blame the bearing, because somebody killed the bearing. So this is the signal immediately after installation. It's already dead, but he doesn't know that yet. So it's a dead bearing immediately after installation. You just need to look at the toolbox of the guy. There are 3 sizes of hammers. But if you don't do the check after with the proper technology, you will just let it go. And you will have a failure after 2 weeks. So this is in Turkey, chemical plant extraction fan. Found on time. It was outer race defect. You can see it even in the spectrum if you want. Quite straightforward, done by a maintenance technician. And this is in Austria, construction material manufacturer. Again, maintenance technician on a dryer fan bearing. Quite straightforward. This was still not visible in vibration because we did both. So those are just randomly picked cases that brought a huge, huge, huge benefit to the company. By benefit, I mean money. Let's be very simple and straightforward. The benefit for the company is the money. So process team, maintenance technician, condition monitoring team, operators. Reliability is everybody's job. Reliability is not job of the reliability department, because by the definition, reliability department is not doing reliability. Reliability department is making strategy and the plans. The reliability is executed by people who are touching the machines. Condition monitoring by itself doesn't improve reliability. So that's another myth that people try to believe in. Condition monitoring doesn't improve reliability. So if you go to the doctor and doctor gives you a diagnosis, so what, you feel already better? No, now you have to do something about it. So condition monitoring is diagnosis. And now you have to do something about it. And then you will improve reliability. Just by having diagnosis, nothing really changes much. So reliability is everyone's job. Mindset shift in industry is very important. People's brains. Industry 4.0 is great as long as you have people 4.0. You need them. So more people using technology, more involvement, more improvement, more discovered talents. Because you need more people in this higher part of the pyramid to go up and multi-technology approach. Because all this exists. All the technology exists. There is no excuse for the failed bearings. When the bearing fails, there must be somebody, name of the person who is responsible for that. As long as there's no name, you'll have problems forever. Because bearings do work properly for a very long time. If they fail, it's somebody's mistake. So I hope there will be kids who will one day say, I want to be a grease guy. That would be nice. Thank you for your attention.
Thank you very much, Haris, for this insightful information.